Okay, here's a couple of gas law questions. It says, what the volume of a gas balloon? Let's just do our thing here. P1V1 N1T1 P2V2 N2T2. What is the volume of a gas balloon filled with 4 moles of oxygen gas when the pressure is 98.0 kilopascals and the temperature is 30 degrees? Okay, we have to add Kelvin to that. So that would be 303.15. 303.15. Now notice they're not giving us any second pressures or volumes. So if they're not, then the formula I need to use is PV equals nRT. Since I'm searching for volume, I'll divide both sides by P. So it'll be nRT over P. The moles are 4.00 moles. R is 8.314 kilopascal liters per Kelvin mole. The temperature is 303.15 Kelvin, and the pressure 98.0 kilopascals. So the pressure's in kilopascals, that works out good. Kelvins cancel, moles cancel, I'm left with liters is what I'm looking for. Now I just have to do that on the calculator. Whoops, where's my calculator? There we go. Okay, so I want to go 4. Okay, 4 times 8.3. 4 times 303.15. And then I'm going to put a bracket to close the top, divided by 98. Okay, so my answer comes out to 102.873 liters. But I need to round off, right? So I need to round to the nearest 3 sig figs. So I'd call that 103 liters. Okay, in this next question, let's do the same thing. So they say, what pressure is exerted? I want to know pressure. When you have this many grams of xenon. Now, I have moles here, but I don't have moles, I've got grams. So I need to use this formula right off the bat to figure out how many moles that is. So 54.0 grams divided by xenon, right there, oops, 131.29. 131.29 grams per mole. Grams cancel. Let's do that. 54. Okay, 54 divided by 131.29. Okay, 0.4113. 0.4113. Moles. Okay, so now I have moles. 0.4113 moles. Volume is 10 liters. And then the temperature is 20 degrees. So to get my temperature, it'd be 20 plus 273.15. So that's 293.15 Kelvin. Okay, again, I'm not changing pressure, volume, or moles, so I don't need these here. And again, I'll be using the same formula as last question. PV equals nRT. This time I'm looking for P. So P is equal to nRT divided by the volume. Moles, 0.4, whoops, 0.4113 moles. 8.314 kilopascal liters per Kelvin mole times temperature 293.15 Kelvin divided by the volume 10 liters. Okay, so moles cancel out, kelvins cancel out, liters cancel out. I'm left with kilopascals. So that's awesome. Okay, let's bring the calculator in. Okay. Oh, now I can use that same numbers I had before. So 54 divided by 1.29, that's my moles. So times 8.314 times 293.15 and the top with a bracket divided by 10. Here we go. So the pressure is 100.2448 kilopascals. Let's look for sig figs. 3, 4, 3. Let's go with 3. So that would be equal to 100 kilopascals. Okay, hopefully that helps you with those two questions.